Good morning. I'm going to talk about our project, which in English sounds like development of criteria for temporary closing, reopening of the seismically active mines due to seismic risk. It's a little bit in the other order. So LTO is the leader of the project, and our partners in this project are LKB and Boliden. The project is working with Kiruna Mine and Garpenberget Mine. And officially, we have consultants from Poland and Australia. But in the course of this project, we attracted also people from Italy, Austria, Bulgaria, and we actively work with people from Poland. So why do we need to do this project? We know that there are a few mines in Sweden which are comparatively deep, and the depth right now is in the order of 800 to 1,000 meters. This creates a challenging problem because deep mines are also create seismicity, which is induced by the mining. And at some point, this induced seismicity can create damage underground, also casualties. And there are some things we can do. One of these things is temporary to close some areas in the mine. So people will not go there, and at least there will not danger for them, and it will be safe to continue mining. So the purpose and goal of this project is to develop methods and possible criteria for increased seismic and damage hazard. So we are dealing not only with seismic, but also with damage hazard, and some recommendations for closing certain areas in the mines and subsequent reopening based on relationships between mining process, seismic hazard, and potential damage. So if we look at this diagram, we can see that the mining here would create some stress changes. These stress changes underground cause seismicity, and seismicity itself can cause damage. So by looking at these relationships between mining, stress changes, and seismicity, we can develop some kind of prediction what will happen in the future based on this relationship if we know exactly how the mining will progress, how this mining will change the stresses, and what will be the effect of these stress changes. So we are developing something which is called time-dependent seismic hazard, which depends on the mining. Based on this seismic hazard, we can look what the damage could be from some of these seismic events, and then we can develop criteria for closing the mine if we see that there is some high hazard for damage. We're looking also at short-term hazard, which I will describe now. So these are the cases which we decided to consider during this project. First of all, it is nice to know when there will be larger seismic events. And if we know when the larger events will occur, we can close the mine. Actually, this is the most difficult part because prediction of earthquakes is not possible, but we are still trying. So this is so-called short-term hazards. So we are looking for indicators that will show that there will be some larger seismic events. We are looking also at some cases when we know that there will be some increased risk of seismicity, and this is after large seismic events, because after large seismic events we have large seismicity after blasting, and if we know that the stresses will increase. So this is what we are doing right now. We are looking at some patterns of seismicity after blasting, looking how far the seismicity go, how long it will go, and also looking at this aftershock series after large seismic events. And the most challenging thing that we are now developing is relationships between production parameters and induced seismicity. This is also our work forward. We have to continue working on these correlations, find the correlations between seismic hazard, local conditions, damage potential, and to develop new technologies for estimation of future damage. So at the end of this project, we're hoping and aiming to get new software that will help the mine to look at the map and to say, yes, here we're expecting some larger seismic events, or we see that seismicity is increasing, so we should close this area, and we will close the area for 3 hours or 5 hours, depending on the situation. So this is our project.